for the most part, you're given a formula. What you're going to need to do in this unit on the exam is use a formula, understand what each of the variables mean, and they'll give you what they mean, and be able to plug them in. So this is still using the same interest formula, compound interest formula. We got 4 years ago, he invested in an RSP. The interest rate was 5%. It is now worth $2,500. So the $2,500 would go in here. We don't know how much he originally invested, so we're trying to find P. Interest rate is 5%, compounded quarterly, which means 4 times a year, and it was 5 years ago. We're not solving for an exponent, so all we need to do is get P by itself by dividing both sides. And I'll just do 20 there and getting our answer. And did he get 1950? 02? It's 4 years ago? Oh. So this has to be a 4. And this is 16. Thank you. And did you get $2,049.37? Because that's what normal people invest at a time. A nice number like that. So I'm going to get you to try and solve this one. Plugging everything in. We want it to grow to 500. We start with 200. The interest rate is 3% compounded quarterly, and we don't know how long it's going to take. Again, it is nice with these questions if you simplify them first by dividing. So I'm going to divide both sides by 200, and then I get 2.5 equals 1.03 over 4 to the 4t. Before I do my logs, just because I have less zeros I have to write and I have less things I have to expand with logarithms. So what's happening to go from 2 to 500 is our amount is more than doubling. It's 2.5 times bigger. Now I'm going to take the log of both sides. Take the natural log as well. The 4t can come out in front. Because now that 4t is the exponent to the whole thing. To find out what t is, we're going to have to divide. Log 2.5, you're going to have to divide by 4, and log 1 plus 0.03 divided by 4. And someone who's already calculated, how many years is it? 30.66. 30.66 years. Excellent. Now what often happens in an exam is they'll give you a question like this, and you start with writing your formula, and you don't know the amount, and you don't know how much it's worth later because you don't know how much the initial amount is. So you only know so far this part, and we know we need to solve for t. Well, what we talked about before, that it takes the same amount for a penny to double as it would for $10 million to double, the same thing is true when something triples. So you could choose any amount that you would like to for here. You could pick $100, then it would triple to $300. You could pick $1,000 and triple to $3,000. You could pick $1 billion and write a bunch of zeros and then have to write a bunch of zeros on the other side. Or you could just use $1 and say that it's going to be triple or $3 over here. That's the nicest because in either one of them you'd have to divide anyways to get it to this point. Then we can solve by taking the log of both sides And it doesn't matter if I use natural logs or logarithms, so I'll keep mixing it up just so you get used to the idea that it doesn't matter which one you use. And now you would divide by the 12 and the natural log. And we'll get the same answer whether you use the natural log or the log. And someone who's got it? Yeah, this is 0.5. Did I miss a 0? No, there. Sorry? 22.03? 22.02 years. Nice.